In this video, we are studying trigonometry, which is the study of triangles in relation to their sides and angles. So we'll be dealing with trigonometric ratios. And what are trigonometric ratios? Trigonometric ratios are just sine, cosine, tangent, cotangent, cosecant, and secant of angles. So we'll be understanding what ratios give about those names I just called now. Okay, so but first of all, before we go to the trigonometric ratios, it's important for us to understand that in a right angle triangle like this, with this side as angle 90 and then this side as a certain angle called theta. For example, that this side of the angle, because trigonometry, that is, we are dealing with the sides and angles of a triangle. So this side of the triangle that is opposite angle 90 is called the hypotenuse. So for short, I'll be writing hype, but that is the hypotenuse. And then this side that is opposite this marked angle is just called the opposite. And then the remaining side is called the adjacent side. Oh, ADJ for short. Okay, so that's the most important thing for us to do. This side, the hypotenuse, does not change for any reason. It's always that side of the triangle that is opposite angle 90. But the opposite or adjacent might change depending on the angle being considered. As we consider this angle, this becomes the opposite and adjacent. When we consider this other angle, this side becomes the opposite of the angle, and this side, the remaining side, becomes the adjacent of the angle. So that is the important thing to note. Now, the basic trigonometric ratios are sine, cosine, and tangent. So for short, sine, cosine, and tangent. So we'll be using SOHCAHTOA. To find out how these trigonometric ratios are gotten. Then SO stands for the sine of an angle theta. That the sine of angle theta is equal to this O represents opposite, the opposite side, the length of the opposite side over the length of the hypotenuse. H represents hypotenuse. That's what the ratio sign means. So for cos, the cosine of the angle theta for this triangle is equal to adjacent over hypotenuse. So adjacent over hypotenuse. And then that tan of an angle theta is equal to opposite over adjacent. Now, for all these basic trigonometric ratios, for each of them, they have a reciprocal. The reciprocal of sine is secant. That is cosecant. So we say that cosec theta is equal to, it becomes hypotenuse over opposite. Just exactly the reciprocal of this, or equal to 1 over sine theta. So for cos, the reciprocal of cosine of an angle is the secant. So it's equal to, or sec for short, is equal to, you guessed it right, hypotenuse over adjacent. Then for tan, we say cotan. that is cotangent, becomes adjacent over opposite. So that is it for trigonometric ratios. Now we'll be seeing the trigonometric ratios of basic angles. Now we'll be looking at how do we obtain the trigonometric ratios for angle 45 degrees, for example. So we have this right angle triangle. So this is angle 90, this is 45. So if this is 45, this is also 45. But let's just consider this side as just angle 45 degrees. So considering this angle, this becomes the opposite, and this becomes the hypotenuse, right? And then of course this is the adjacent. Now for this triangle, let us assume that the opposite and the adjacent are 1, the units of 1. So from Pythagoras theorem, the hypotenuse becomes equal to root 2. Pythagoras theorem. So this is the opposite, this is the adjacent, this is the hypotenuse. Now let's look at sine. So let me write out so for sine of the angle 45, sine 45 is equal to opposite, which is 1, over hypotenuse, which is root 2. And if we should rationalize this, that means you're multiplying both the numerator and the denominator by root 2. So we'll have it as root 2 over 2. So this is the basic ratio for sine 45. Okay, so same thing with cos. We are to consider cosine of the angle 45 degrees is equal to, cosine is now adjacent over hypotenuse, which is still 1 over root 2, which is equal to root 2 over 2. Because we have to rationalize. We don't leave the sword at the denominator of a fraction. Okay, so for tangent, that is tan 45, tan 45 degrees becomes adjacent over opposite, that is opposite over adjacent. So that is 1 over 1, which is equal to 1. So tan of the angle 45 is equal to 1. Okay, so this is for angle 45. We'll now be looking at angle. So angle 60 and angle 30. So for that, we consider an equilateral triangle. So which means that all the three sides are equal and all the three angles are equal to 60 degrees. So this very angle will be having it in such a way that we are going to bisect this angle here. So giving us 30, and then we have 60. So bisecting it means that it cuts across this third side at angle 90 degrees. So as this was 2, this part becomes 1, this is 2, so this is root 3 by Pythagoras theorem. So this triangle gave us 30 and 60 degrees. Now let's see the trigonometric ratios for sine 30. Let's start with 30. So sine 30 degrees is equal to opposite over hypotenuse. So this is 30 degrees. Its opposite is 1. And then the hypotenuse is 2. As simple as that. We have that for cosine 30. We have it's equal to adjacent over hypotenuse. So the adjacent to 30 is root 3. Hypotenuse is 2. Then for tan 30, we have that tan is equal to opposite over adjacent. So we have that for 30, opposite is 1, and then adjacent is root 3. Now we are not going to leave this like this. We have to rationalize, which is multiplying both the numerator and denominator by root 3. So we have it as this. Okay, so let's look at the trigonometric ratios for 60 degrees. We have that for 60 degrees, we have that sine 60 degrees is equal to opposite. Opposite of 60 degrees is root 3, and hypotenuse for this triangle is 2. Now, for any angle 60, this is just the trigonometric ratio. For cosine 60, cos 60 degrees is equal to adjacent to 60 degrees, which is 1, over the hypotenuse, which is 2. So cosine 60 is half. Now for tan 60 degrees is equal to opposite over adjacent. So opposite to 60 degrees is root 3, and then adjacent to 60 degrees is 1. So root 3 over 1 is equal to just root 3. Now, there is a simple method for us to remember all these ratios, because in solving, most times, especially when you're solving without calculator, most times you have to deal with these ratios. They are standard ratios for these special angles, angle 45, 30, and 60. Now, I'm a right-handed person, so I'm going to use my left hand. If you're a left-handed person, you're going to use your right hand. Now, this is my palm, and then I'm going to name these fingers. This pinky is angle 0 degrees. The ring finger is angle 30 degrees. The middle finger is angle 45 degrees. The pointing finger is angle 60 degrees. And then the thumb is angle 90 degrees. So we'll be using this to remember all these trigonometric ratios. That's to have them in mind, to know, okay, that tan 60 is root 3. So let's start with angle 30 degrees. So for sine, we say the root of the number of fingers below that angle on your palm over 2. That is how to find sine of any angle that I mentioned on my fingers like this. So the root of the angles below, the root of the number of fingers below over root 2. Over 2, just 2. The root of the number of fingers. So let's just use 30 degrees to just denote that. So sine 30. So this is angle 30 degrees. My ring finger is representing angle 30. So how many fingers are below angle 30? That is just one finger. So root 1 over 2. And root 1 is equal to 1. So sine 30 is just 1 over 2. And you can see that over here that sine 30 is 1 over 2. Now, for cosine of angles, it's equal to the number of fingers above that angle. That's the root of the number of fingers above the angle over 2. So this is my palm. For cosine 30, this is 30 degrees. So how many fingers are above here? We can see that it's 3 fingers. So root 3 over 2. You can see that cos 30 is root 3 over 2. Now for tangent of angles from your palms. Tangent is equal to the root of number of fingers below that angle on your palm over the root of the number of fingers above. So it's simply called a sine over cos. But let's see that. So we have that this is angle 30 degrees. Root of number of fingers below, so root 1 over root 3. So we have that root 1 over root 3. Root 1 is equal to 1, and then this is that 1 over root 3. So when we rationalize, we have it as root 3 over 3. But that is basically that. Now, having seen this, you could try that out for sine 60, cos 60, tan 60, even 45. Then for 90s and zeros, for sine 0, the number of fingers below angle 0 on the palm is 0. So that is root 0 over 2, which is just 0. Sine 0 is 0. But for cos 0 is equal to the number of fingers, the root of number of fingers above over 2. So number of fingers above 0 is 4, right? So root 4 over 2. Root 4 is 2. So 2 over 2, that is 1. So cos 0 is equal to 1. Same thing with 90. Just try that out for 90. Check that in a calculator or in a table. And then you find out that your fingers can actually help you to remember the basic trigonometric ratios. Now, before we end this video, we are going to be applying what we've learned so far to solve for the sides of angles. For this triangle, we've been asked to find the side W. This is just W, the side called W. So this side is 3. We are not given this side, and we're given that this angle is 60 degrees. So to find this side, the hypotenuse, which is this side opposite, so I'm going to just name all the 3 sides of this triangle. This is the hypotenuse. This is just W. Hypotenuse. Now this is the opposite. So considering that in this triangle, we are given the opposite and we are looking for the hypotenuse. So we are just dealing with opposite and hypotenuse. So we are going to say, and then what reminds us of that? Let me write out so katwa. So always write this out when you're solving triangles like this. So we can see opposite hypotenuse and it is sine. So we are going to use sine. We are going to say that sine 60 degrees, which is the sine of the angle given to us, 60 degrees is equal to opposite, which is 3, over hypotenuse, which is W. Okay, we are going to cross multiply. When we cross multiply, we are going to find out that W times sine 60 is equal to 3. We are dividing both sides by sine 60 so that W can just be divided by sine 60 divided by sine 60. It goes away on this side. Now remember our palm, sine 60. So this is angle 60, the pointing finger. Sine 60 is equal to the root of the number of fingers below, that is root 3 over 2. We have that W is equal to 3 over root 3, or just let me use this, 3 divided by 3 over 2. So we can change this to multiplication. When we convert this to multiplication, we have that W is equal to 3 times 2 over root 3. So when we have that, we see that it's equal to 6 over root 3. Now we can't leave our answer like this, we have to rationalize. In order to rationalize, we have to multiply all through by root 3. Okay, so root 3 times root 3, that is giving us 3. 3 dividing 6 is 2. So we have that the side W is equal to 2 root 3. So we could see how that helped us. Without using tables or calculator, we are able to solve this triangle. So go ahead, try out other triangles to see how this works.